Good morning, engineers. This is Mr. Heller getting ready for week 2 of engineering work at home. We're going to have to look at some new learning this week. So we're going to be looking at equations of linear motion with uniform acceleration. Let's take a couple of these words and look at them. So linear motion just means something that's moving in a straight line backwards and forwards. Could be going to the left, could be going to the right, could be going to the left then the right, could be going up and down, could be going down a straight line down a hill, but it's a straight line. We're not talking about rotation in this section of the course. And then uniform acceleration. That means something that's uniform. Uniformly just means steadily accelerating or decelerating. Could be speeding up, could be slowing down, could slow down, turn around and then go in the opposite direction. But the acceleration is constant. So in this case, we're going to be looking at things traveling in a horizontal line under uniform acceleration. We'll look at some things with gravity next week. Okay, so in the formula booklet, we've got the set of 4 equations here which all relate to a final velocity, an initial velocity, and velocity is just like a speed, but it's got a direction, so it could be positive or negative. Acceleration, in this case, if it's positive, we'll say it's accelerating. If it's negative, we'll say it's decelerating. Time, and a distance. So that could be distance forwards if it's positive, or distance backwards if it's negative. And usually we'd see these written down SUVAT. So sometimes you might see them referred to as suvat equations. And you'll notice each one of the equations links 4 of these variables together. So this one links all of them apart from V. This one links all of them. This one links all of them apart from S. This one links all of them apart from V. This one has got no T in it. And this one has got no A. So even though there's an acceleration happening here, we don't need to know, and we can't calculate the acceleration using that one. So depending on the values that we're given and what we're looking for, we're going to pick one of these 4 equations. There is a 5th one as well, which you'll see written down some places, which doesn't involve U, but we're not going to look at this one because it's not in the formula book. Okay, so I'm going to jump in to an example question. This one actually comes from this January's past exam paper. Okay, so it says, a car is on a road with a set of traffic lights ahead. The car starts at rest. That's really important that we notice that it starts at rest. So when I write down my variables here, we can say because it's starting at rest, the initial velocity, u, is 0. It's starting at rest. It accelerates at a constant rate of 3 meters per second. So I'm just going to write down 3 there. And it accelerates for 8 seconds. So I'm going to write down an 8 there next to time. Now, in this case, everything's in meters and seconds, so I don't need to do any conversion. If we were in kilometers or hours, I'd need to convert it to meters and seconds before I start. Then it says calculate the velocity of the car after 8 seconds. So I don't know what velocity is. You'll notice here, I've not got a distance, and I'm not trying to work out a distance. So I can kind of ignore that for now. So let's have a look. Well, I want to find the formula that doesn't include S, because I'm not looking for it and I don't know it. And actually, that's this first equation up here. So I'm going to say that V equals U plus AT. Just a quick bit of substituting in. Gives me V equals 0 plus acceleration 3 times 8 seconds. So I can say V equals 24 meters per second. Okay, first bit done. Second part of the question, the car then decelerates at a constant rate of 4 meters per second squared. So let's start putting some of this information into our little table here. Right, the car then decelerates at a constant rate of 4 meters per second. Well, I've noticed it's decelerating, so I'm going to call my A minus 4. And it stops at the traffic lights. So the final velocity is 0. Calculate the distance travelled. Remember, distance is S. Now, it looks like I've not got enough information. Well, it says the car then decelerates. So it started decelerating when it got to 24 meters per second. So time, not looking for time, don't know it, not bothered about it. This is the formula that doesn't involve time. So v squared equals u squared plus 2as. And in this case, I've got a little bit of substituting to do. 0 squared, 24 squared, plus 2 times minus 4 times s. A little bit of rearranging gives me s, where s is the distance, remember, is equal to 24 squared Now obviously I could have evaluated 24 squared before I started. I'm just going to work that out as 72 meters. Okay, there we go. Let's have a read of the question. The car decelerates at a constant rate of 4 meters per second squared and stops at the traffic lights. Calculate the distance travelled by the car while it's decelerating, and that's a distance that I've worked out there. Okay, so a few more files that I've sent along in the email. One is this formula sheet. I've sent these questions as well. If you want to have another go at these on your own, I've sent a worksheet with some answers, and then another past exam question that I'd like you to have a go at, and email me your answers. Okay, see you next week.